Jim Joe Bob Billy Jim here in the esteemed Mr. Niedermeyer's classroom, and we are trying to figure out why they say water is so important to life. Because NASA's spending billions of dollars, taxpayer dollars. I say that because I'm not a taxpayer, but spending lots of money to see if there's life on Mars. They keep telling me, if there's water, there's life. If there's water, there's life. So apparently water is important. But why is water important to life? I don't know. Let's find out. So what we have here is a station, not a gas station. Spent a lot of my formative years at the gas station. No, this is a station where I'm trying to figure out what some of these properties of water are. I tried to look them up on the multiple listing service, and it was not that sort of property apparently. No, what we have is something about water that allows us to do something. So one of the properties is cohesion. And so I heard that word cohesion before. It's kind of like co-ed. I don't get invited to many of those functions. But we're talking about cohesion. I've heard about cohesive teams, so maybe it has something to do with that. And we had a couple elk hunting trips where I thought we were pretty cohesive, came away with a couple of legal bulls. So I'm going to stick this paper in here, and I'm watching it. Only a little bit is touching the paper. Come on, cameraman, get closer in here. Lean in, cameraman. We got to see how far up this water's going. The water's going up pretty high. It appears that water's going up. Now, station says that's cohesion. I don't know what that is. Station says I should use these to figure out what cohesion is. I don't know what cohesion is. I don't know if I'm holding it and staring at it in the face. If water had a face, I don't know what part of it would be the face. It's kind of like the man in the moon in that way. I don't know. So, cohesion, some important property. So next station we have here is surface tension. Apparently it is related to cohesion. I don't know in what way. What I do know is I know surface tension. Surface tension is like when I walk in to a group of vegetarians toting a field-dressed armadillo. So surface tension says what I'm supposed to do here is see if I can't float a staple on water. So let's see what I can do here. See if I can float a staple on water. There it is. Bam. First try. Like muzzle loading a 22. So now I'm going to try to float a staple on oil. Here it goes. Just as careful. Always better the second time. That's what they say about gumbo. That didn't work. Let's try that again. Why can't this thing float? I haven't failed anything since second grade. It's not going to float. It just ain't. So, something's up here. So, surface tension. Apparently no surface tension. I don't know what the problem is. It also says I should be doing something with these guys. Pencils and these guys suggesting that I can illustrate visually surface tension. I don't quite know how to do it. Maybe you can. We'll see. Apparently, water is known as the universal solvent. I don't know what solvent is other than you're supposed to use a solvent when someone puts cat urine in your gas tank to clean it up. So, what they've given me here is salt and water. Now apparently in places that are along the coast, I have not been to one of these places, they say the water is salty. I don't know how that's possible, suggests something happened. So we're going to dump some salt in there and we're going to stir it up with our officially licensed stir stick from some fine corporation called Westcott. Stirring it up. The salt's gone. The salt is gone. How the heck? All I can say is the salt is gone. I got this bowl. Apparently, I can illustrate it here same way. I don't know how. What would that look like in here at the molecular level? I don't know. Maybe you can figure it out. Okay, so we have here water in a beaker that looks suspiciously like the same one we use for salt. It's a coincidence, I'm sure. And it says here that ice floats on water. I know this because I've had a few cold Pepsis in my time where I've floated a couple ice cubes after some hard work on fencing. My wife's still yelling at me about not quite done yet. And so we throw the ice in there and it floats. Now you put just about any other solid in there. Heck, you put a molecular representation of water in water and it floats too. That's interesting. That was unforeseen right there. We need something that's a little different. Maybe we'll try one of these. See if this thing... Ha! There we go. That's solid and it sunk. It appears that solids most of the time sink. I throw a rock in here, it's going to sink. At least I hope it does, or else my worldview, woo, all messed up. So, my question is, why does ice float? Now, when I start putting these things together and just playing like a puzzle, you know, that's how I am. This is about as difficult a puzzle as I can do. Those 15-piece dinosaur ones people think are from my son. But that's about as good as I can do. And yet I made this, and there's a lot of space in there. Is that why ice floats? And why do I float? People say, because Jim, Joe, Bob, Billy, Jim, you ain't fit like you used to be. I say, but if you look at me from the front, that's all stud. From the side, no, from the front, stud. But is that why I float? Because I got holes? Or is there something else going on? So we got to figure this out.